Okay, so I think I'm live, right? Radhe Radhe everyone. I'll just quickly check with from my side. If anyone is over here in the live chat, just let me know if I'm live or not. Like if you guys can properly hear me or not. Okay. Okay, I'm properly audible, right? Yeah, great. That was from my end. So let's start with. Mm, oops. From where is the voice coming though? Do you guys also? Oh, okay, okay, okay. I forgot to put out desktop audio. How to do that? Uh, it is still coming, right? I think if I do it like this, then it's gone, right? I don't know from where it is coming still. Can you guys also hear like whatever I'm talking right now? There's like why is it happening like this? It never happens like this. 0 decibel mic box. I'm not properly sure whether I can like stop streaming over here and then reset it or not. I'm not sure. But I think now it is fixed, right? It is not coming anymore, which is good. Okay. So you guys can hear me, right? So you guys can hear me, right? Okay, then leave it as it is. I don't know what the heck is wrong with it. Let me just do one thing. Best. Yeah, I think this is good. Well, sorry for the delay, sorry for the this thing, for the inconvenience. Let's start with the video, okay? So the first problem, it goes like 2 2 2 2. I don't know what the heck is this problem about. So I have to go to reading the question. It is a very simple question. It is given that you're given a string S consisting of digits. Remove all characters from S except for 2 and then concatenate the remaining characters in the original order to form a new string. Okay, which is a very basic thing, very basic thing to do. Okay, it is just basically telling you guys that you're given a string. From that string, what you're going to do is nothing else. You just remove all the elements that are not 2 and keep all the elements that are 2. So I think I can explain you guys this, but okay. So let's. Can I see like when was this posted or something like that? Because this even happened that day. Like there were people in the lobby, but when I started the stream, there were not much people on the code shift day. So yeah, okay. So let's start with it. Okay. So what you can do is basically it's very simple. Since you know that you are going to have a string, so let's say the string is going to have various elements. So let's say there are some zeros, then there is a 1, then there is a 9, there is a 8, there is a 2, 1, 2. So basically what you have to do is you have to remove all the elements that are not 2. That is this, and this. And then concatenate everything. हाँ क्या बताओ E डायरेक्ट E जानना है. So basically you can have them directly out there, and then what you can do is you can just print the twos. Okay, if you want to see the code, I'll just quickly go through the code because I think this was a very basic thing. You're getting a string, taking it. This is very logical. This I was just trying. So whenever you encounter there's a 2, just print a 2. Okay, nothing more than that. So let's move on to the next question. Okay, हो सकता है. No, no, not a new YouTuber, the old one only. I think that is the reason even in the previous course stream there were not much people. Okay, so let's get on to the next problem. Okay, so this is cat. You're given n strings s1, s2, s3 till s of n, consisting of lowercase English letters. The length of these strings are all distinct. Sort the strings in ascending order of length. This is also very simple. You have to just sort them out in ascending order. So let's say if I'm having various strings, so what you can do is you can just use the sort function with the comparator based on length. Okay, clear? If you want to go through the code, I'll quickly walk you through the code. So this is the comparator, and this is what I'm doing, sorting it and then I'm printing it. Okay, let's move on to C. Well, what C tells us is you're given a string S consisting of uppercase English letters. Apply the following procedure to S and then output the resulting string. Okay. As long as the string contains WA as contiguous substring, we have to repeat the following process. Among all the occurrence of WA in the string, replace the leftmost one with the AC. Okay. So what does he mean? He means that if in a string you're having at one position W and the next position is A. So you have to remove C and D are stack. Not stack exactly. C was more of a greedy approach also. Why would you need big O and I mean space? You won't need it also. So since you know that we have to make a WA as AC, okay. So what I can do is I can remove this WA and make it AC. But what happens if this A that is created now makes another WA? Okay, which means that initially there was a WWA. Okay, so now what happens? This WWA, first of all, this WA becomes AC, and this WA becomes AC. Okay, then this WA becomes AC. So this becomes AC. Okay, so basically you can see there is a pattern that whenever you're having various number of W's and then A, so it basically makes that whole substring as A C C C C C C C C. So what you can do is simply, let's say, so what will happen? This whole thing, it becomes A C C C C C C C. Okay, but how to do this in one go, in one complexity? That is, you just traverse from the right to the left. Okay, instead of traversing from the left to the right, traverse from the right to the left. And what you are going to do is, since you know that a WA, even after removing, can only form another WA if there is a W just before it. Otherwise, there is no other condition. Okay, otherwise, what you can do is you can simply remove all the WAs and make it AC. Right. So, what you can do is, since you know that a WA at this position, if I'm putting it as AC, it is going to put a WA at a position just before it. So what if I don't do any operation on the elements just before it? I just start doing the operations from the right to the left. That is from the end to the beginning. Okay, so it's a better approach for us. So what we can do is we can go on traversing this, and then whenever we find that there is a and there is a W before it, so make this AC. Now again you find that there is a and W before it, so now again make it AC. Okay, and you go on doing it till it becomes ACC. Okay, simple. If you want the code, let me walk you through the code. What we are doing is basically nothing else. We're just checking for the is balanced. What is is balanced? Oh, sorry. Yeah, so we are just doing nothing else. So what we are doing is we are checking if there is a W at the previous position and a at the present position, then we are making it AC. Okay, nothing else. As simple as that, and this will work. Okay, now let's move on to D. What is D? D tells us colorful bracket sequence. It is simple. I won't walk you through the question. I'll just explain what is the question. It is telling us that there will be three types of bracket: this, and this, and you have to find out whether the whole thing is a valid bracket thing or not. So, what is a valid bracket thing? So, let's say if I'm starting this bracket, and then I'm ending with this bracket, and then I'm ending with this bracket, and then I'm starting with this bracket. Right? This is not a valid thing because I am starting this bracket, and then instead of putting this bracket before this, I'm putting it after this, right? But if the opposite thing happened, that is this was there and then this was there, so this will be a valid thing. How to do it is very simple. You will find this kind of problems a lot in lead code, vagera, vagera. You will find a lot of this kind of problems. So it is basically stack only, as Akshat was telling us. So let's say if I'm having like this. Okay, so what you're going to basically do is whenever you find that there's something opening, you can put it in the stack. Okay, and once you start that it is closing, so you have to find the last position that it opened. Okay, so if it is the last position, so you cancel it out. Then you go over here, the last position, to cancel it out. Then you, since it is the opening, so you put it in the stack. Last position, cancel out. Last position, cancel out. At the end, the stack will be empty. Okay, if you want another example, I will quickly go through another example. Okay, so what happens in the stack, I'll just show you. This I'll just use the eraser. Okay, so I remove 1, 2, 3, 4. Okay, which makes it 1, 2, 3, 4. Now since I'm having this closing, so I can remove this close. I'm having this closing, so I can remove that corresponding open. I'm having this as closed, I can remove this. Then I'm having this opening, so I have to again put it in the stack. Then I'm having this closed, so I can remove both of them. I'm having this opening, so I can put it in the stack. I'm having this opening, I can put it in the stack. I'm having this closed, I can put it off from the stack. I'm having this closed, put it off from the stack. Closed, closed. Okay. After all the operations, the stack will be empty. If the stack is empty, it's a good thing to go with. If it's not, then it's not a good thing. And if at any position you found that the closing bracket was this, okay, the closing bracket was this, but the top of the stack was this, which means that the closing and the opening bracket doesn't match. So in that case also it's a no. If you want me to walk out through the code, I'll just quickly walk you through the code. What I'm doing is if I'm finding that there is any of the opening, I'm going to simply push it into the stack. And if I'm finding any of the closing, so I have to check if that stack is empty. That means that if there is no closing bracket only in the stack, so I can directly say that return false. Sorry, we can't go with it. You're closing the bracket without even opening it. It's a false. Otherwise, we have to check with the top element, and we have to pop it out. If the top element and the present element is having the same thing. What do I mean by same thing? That is, third bracket is closed by a third bracket. A first bracket is closed by a first bracket. An angular bracket will be closed by an angular bracket only. Okay. So you can see that I'm checking for 3 cases. I'm returning that if any of them is not valid. So what I can say is that it's a false. Otherwise, return true. Okay, not return true. What we have to do is return if the stack is empty or not. That is what I just explained, that at the end the stack needs to be empty. Okay. Is everything clear? Like, I am going too fast, is it clear? Should I move on to E? Tell guys, tell. Should I move on to, okay, Akshat is watching this video for E only. Okay, so the problem statement is palindromic shortest path. We have directed graph with n vertices, 1 to n, and the information is given about n squared characters, where C of ij is the, I'll just do one thing. C of ij is the lowercase English letter or dash. Can you also explain F problem of 393 beginner contest? Okay, I'll just walk through. If I can, though, I will explain again. Because like E was difficult, man. E was difficult. If C of I comma j is a lowercase English letter, then there is exactly one directed edge from vertex I to j, labeled C of I comma j. And if C of I comma j is dash, that means there is no edge. Okay, so you have to find out what is the shortest palindromic path from I to j for every specific pair. I think this I will explain with an example. Okay, I'll explain with this example. Okay, see, what does it mean? So you have to see this thing as a, what to say, as a 2D array. Okay, that is, let's say since I'm having 4 edges, so I'm marking them out. Okay, 1, 2, 3. I'll use a lighter brush. Okay, 1, 2, 3, 4. Okay, now see, 1 is connected to itself with the A. Okay, A. 2 is not connected to itself. 3 is also not connected to itself. 4 is also not connected to itself. Now 1 is connected to 2 with B. Okay, there is a B. And okay, in case you guys can't see this, it is 4. Okay, Obviously, this is like, you guys can understand that. And 2 is connected to 3 with B. Okay, so this is also a B. And 3 is connected to 4 with a A. And 4 is connected to 1 with a C. Okay, clear? The whole thing, the whole whole structure, what it means, what is it all about. Now for every pair we have to find the shortest distance, which is a palindrome. Now a basic approach that may come to your mind is, why shouldn't we go for a BFS approach and do it? Okay, see, I haven't tried the BFS approach, but I think that BFS approach will be giving you a TLE. And I'm not sure, like, if Akshat, if you have tried the BFS approach, topo sort. Yeah, topo sort will also work over here, but I have a different approach. Okay, see, now since I know about this. Okay, I can tell you something, and I can even prove it to you. That is, if I find out the shortest distance between any two pairs, okay, just a minute. Huh? Okay, so yeah, since I know that there is a shortest part between them, okay, which is like this, which means that what I can do is I can find out one thing for sure, that there is a path between them. Okay, so let's say there's a path between them, and it may not be the shortest, but if there is a path between them, we are first of all, whenever we are going to search for the paths between them, we are going to take off the fact, completely take off the fact that there are positions where you can have a specific element pointing to that specific element. Right, we just saw in the previous example that over here A was pointed towards itself only. So in this case, what we can do is we can remove that possibility. Okay, we can remove that possibility, and then what we can have is we can have all of them sorted out. Okay, I can have all the paths that are coming from here and ending over here. But remember one thing, that initially, if I am traversing from one point to another point, which means now I'll just think of this at a very smaller level. Okay, that is, there is one element over here, one element over here, and there are various paths. Okay, and one of the path which should be satisfying our solution is this. Does that always mean that this element and this element, sorry, I'll just use a different color, does it always mean that this vertex and this vertex will be same alphabetically named? Right, you may come across the fact that yeah, it should be always the same, but when I am talking that this is a possible shortest distance, which is a palindrome, remember one thing, at any position there can be phases where it will be connected like this. So there will be a circular, what to say, a circular like iteration inside it, intercircular iteration, intercycler iteration instead of having the intracircular iteration. Okay, so within it only it is happening. So what do I mean by that? Okay, so what do I mean by that? So if let's say I want to find out the shortest distance between this and this, and there are few paths that come out from this, I mean few vertices that come out from this and few vertices that come out from this. Okay, clear? Now this is A, B, C. and this is A, F, G. So which one should I consider? The AA, right? But the problem occurs when there is an element which is somewhat like this, and that is also a A. So in this case, we can have a A and then I can go to any F or G, right? I can have the A any number of times, because whenever you are having something like that, so you have to just sort it out. So it is always a better approach that you find out all the paths, because like if you're initially finding out all the paths, a lot of paths will be already cancelled out. What do I mean by that? Is if one cell is connected to another cell directly, so that is a palindrome, because every string of length 1 is a palindrome, right? So you can get that. So you know that this is going to be of the value 1. So most of the cases, so let's say if I'm having, do you yesterday physics paper of 12, what happened? I think ICSC is ISC is going on, right? CBSC is not. ISC was hard or CBSC was hard? CBSC. Okay, okay, okay. Great, man. Okay, so let's move on back to the question. So, so if we find out the paths, okay, all the paths, because it is from one perspective may seem that it will be giving us a TLE, but it won't. Okay, because if you're finding out all the paths directly, you have already eliminated a lot of paths. Let's say if in the whole grid that was given to me as input over there, a few paths were like this, which means that there is no vertices for this. Okay, and a few parts were filled with some alphabets. So all the parts, all the places, sorry, all the places where there is a X, I mean there is any alphabet. So in that case, I can say that it's a 1, because I can have this relation. One node connected to a different node. If it is directly connected, so the minimum palindromic path is 1. You can see it from here, this example. That is this A and B. So see, B is 1. And why is A 0? Because we know one thing, that the diagonals has to be 0. Because if you're starting from one point and reaching at that same point, the minimum thing is, the minimum distance that you have to traverse is 0. Okay. So diagonals you can directly write as 0. For all the places where there is an alphabet, you can directly write it as 1. And for all the other places, it has to be either greater than 1 or minus 1. Okay. It has to be either greater than 1 or minus 1. Now what you have to do is, like it can be proven, like you don't have to traverse for all the elements. You can just have uh, all the parts of distance k. Okay, I mean n, sorry. So you can have all the parts of distance n. Okay, it doesn't mean that you have to go until 100 also, because before that only you will find out the whole thing that you need. Because if you're traversing till 100, so remember that if you're traversing from this path to this path, and in between there was a specific node, so you have also considered traversing from here to here, right? One of the possibilities you have already covered. So within the first, like if you're traversing throughout all the nodes, you have already covered all the possibilities of traversing from one node to another node, right? And a few nodes you can also ignore, because I just mentioned this condition. Okay, this condition. So if you go by this formula, find out all the distances excluding the points where they are having themselves as looped, internally looped. Okay, you find out them. Now the second step is, if you're having, let's say like this, so if you want to find out whether it is a palindrome or not, what you can do is you can go on checking them. So if this and this If both of them are equal, great to go. You can move on till over here and over here. Okay. But if both of them are not equal, that is the place where you have to think about it. Okay. So if both of them are not equal, you have got two options to do. What are the two options? The two options are basically nothing but like you can internally move inside it, right? So if this element, what do I mean by that is, thank you Rishabh sir. So what you can do is you can move inside it, okay? So let's say if this element and this element is equal, so what I can do is I can move over here and I can just remain over here. Or if the vice versa occurs that this element and this element are same, so you can move from here to here. Okay. But what if there is a tie between them? So you know the basic approach what to do it. Okay. So you can just simply search it. So this is what all the whole algorithm I'm talking about. Okay. This is the whole algorithm I'm talking about. The graph is an undirected tree. Each vertex has degree 1 or 4. There is at least one vertex of degree 4. Determine whether there exists a graph of T that is an alkane. Do AtCoder, something good about AtCoder is like the problems are very hard over here. Okay, so I have done till over here only. I haven't done the remaining problems, and I don't want to do the remaining problems. Okay. So let's do one thing. Let's quickly rate down all the problems for ending the stream. So this is easy, medium, hard, right? The first four problems, F problem of 393. Okay, we can discuss it after rating the problems. Okay, we'll discuss it. If I can do it only, then only. I'm not sure about it. So the first four problems were very easy enough. So the first two problems were easy enough. The C and D was also easy enough, and E was more than medium. May not be hard, but more than medium. So what I have seen something about AtCoder is that the first few problems, till A, B, C, D, what they do is I can't understand a DP state in editorials. DP state. Oh, okay. Problem 393. I get it. So this is the rating of the problems. So what I'm seeing is that AtCoder usually starts with easy problems, very easy problems, and then they upskill the level to such a extent that it becomes really difficult to crack it up. But yeah, AtCoder is training people like that only. Okay, so you wanted the code for, the F problem of 393, right? AtCoder beginner 393. F prefix display. The problem itself seems to be so difficult. The terminology seems to be so difficult. You're given a sequence A is equal to till n of length n. Answer Q queries the ith query, but nothing is. This guy is a friend of mine. Okay, this guy is no subscriber like you guys. You're given integer ri xi. Consider subsequence not necessarily contiguous of a till r of I that is strictly increasing and consists of only of elements. Most find the possible length of such a subsequence. It is guaranteed that you're given integers ri xi. Okay, it's strictly increasing and consists only of elements at most xi. Find the maximum possible length of such a subsequence. Strictly increasing and consists only of elements at most. At most means it should be lesser than equal to x of I. Find the maximum. So this is easy, right? I mean, no, I feel like from this point. Okay, no, it will be easy if I was just given one query, right? Over here, they are having more than one query. I get it. It is like in the first, in the in the first case, 24133. So they are talking about two. Ri is like it is zero based indexing or okay one based indexing. So if I'm taking to the second position, so it has to be 2 4. If I'm taking it to the fifth position, 1 2 3 4 5, and it has to be lesser than equal to 2. So there is only one element that is lesser than equal to 2 in this sequence, right? We can either take this 2 or take this 1. Okay, great, got it. 5 3. I think I have to go through the editorial because it's getting too much. What we can do is we can have a lower bound, upper bound, then dp of okay. Uh, Typically to find the longest, yeah, I get it. What we have to find. Inspect A of I in the order of 1 to n to update the following dp table in place. dp of j equal to smallest value of the final term of. I'll just go through the quickly through the code. Okay. nqn qsn vector vector pair. So it's a 2D vector and every element in that vector is a pair. Oof. So what he's doing is he's just putting back. You know, now m place back is basically nothing but pushback only. Okay, I comma x. That is that ith position is putting x. फ्लैट ले लिया तुम लोगों ने? The smallest value of the final term नहीं, अच्छा कब लोगे? देख रहे हो क्या अभी? अरे भाई तुम्हारे लिए, आपके लिए क्या एक्सपेंसिव रहेगा सर? Consider the definition of the dp above. The answer to query k returns out to be equal to the maximum j such that dp of j is less than equal to x of k in the dp table when inspecting up to a is equal to r of k. Final term of the that can be extracted versus subsequence. अच्छा अच्छा. See, I'll tell you one thing what to do when you can't understand a problem. Copy it, go to chat gpt and ask him to explain it. Okay, ask chat gpt explain this. I, this is the code and I pressed that. The question is बिल्कुल क्यों नहीं? Okay, he got like what I'm doing. Longest increasing up to a given index efficiently. It uses binary search to read EP array and the okay. Maintain a DP array infinitely initialized to track LIS. Use lower bound DP comma A of I to place A of I in the smallest valid position stimulating LIS. For each query ID comma X, use upper bound X to find the LIS elements lesser than equal to X. Do you know what he is doing basically? As much as I can come out from this, what he's doing is he's basically taking out, he's just finding the LIS, okay, till every specific position. Now let's say I have till this position, I'm finding out that what is the LIS till that position. So let's say in that till that position, for to find out the LIS, I'm taking into consideration this element, this element, this element, and this element. Okay, and I'm doing it at the very optimal cost. What do I mean by optimal cost? Let's say instead of taking this element, I could have also taken this element. Okay, but in that case, what we have to find is which is a smaller element. So if this is a smaller element, then take it. But if it is not a smaller element, then take the previous one. Okay, now take the previous one. So you can find out the smallest, just going like the smallest way. You can find out what is the DP. Using DP, you can find out what is the LIS till that position. Okay, and after you found out the LIS till that position, so from this specific selected elements, what you can do is you can provide a lower bound and upper bound. So basically, the lower bound is doing nothing but is helping you to find out the LIS for every DP position. But the main thing is happening when I'm going for the upper bound, so that okay, देखो मैं क्या बोल रहा हूँ ना कि सोचो ये जो चार एलिमेंट है ना इधर तुमको तो दिख रहे हैं, ये चार एलिमेंट में से सोचो ये एक प्रॉपर LIS बन सकता है टिल दैट पोजीशन, ये मतलब इस पोजीशन तक, ठीक है, मैं इस पोजीशन तक बात कर रहा हूँ, इस पोजीशन तक ये प्रॉपर LIS एलिमेंट बन सकता, LIS बन सकता है. व्हाट इज LIS? LIS हो गया एक स्ट्रिक्टली इंक्रीजिंग मोनोटोनिक सीक्वेंस। ठीक है, क्लियर? तो ये 4 एलिमेंट का जो बना है मेरा LIS, अब इसमें से व्हाट आई कैन डू इज, इसमें से लेट्स से कि अगर मैं इसको कंसिडर ना करके इसको कंसिडर करता तब भी मेरा 4 ही होता। ठीक है, बट इधर ट्रिक ये है कि लाइक किसको कंसिडर करना है, इसको या फिर इसको। तो हम उसी को कंसिडर करेंगे जो लेसर है। ठीक है, अगर देयर इज अ टाई तो मैं उसी को कंसिडर करूंगा जो लेसर है, तो इसीलिए मुझे लोअर बाउंड वाला लगेगा। अब जस्ट बिकॉज ये लेसर है तो लाइक मेरे लिए एडवांटेजियस है। पता है क्यों? क्योंकि सोचो अगर मैं इस पॉइंट पे आ गया, ठीक है, इस पॉइंट पे मैं आ गया, थोड़ा बोल्ड वाला कर देता हूँ, अगर मैं इस पॉइंट तक आ गया, अब अगर मैं इस पॉइंट पे आने के बाद मैं, ये मेरा क्वेरी है, ठीक है, और मैं इस पॉइंट से पहले जो भी मेरा एलिमेंट्स था, ये जो ब्लू वाला जो दिख रहा है तुमको, ठीक है, ये ब्लू वाला एलिमेंट्स था, अब इसके ऊपर मैं फिल्टर अप्लाई कर सकता हूँ जो हो गया लोअर बाउंड अपर बाउंड वाला। ठीक है, कैसे? क्योंकि अभी तक जो भी था ना एलिमेंट्स मेरे पास, तो वो ना अगर मैं ऐसे उसके ऊपर बाइनरी सर्च कर लूं तो log n में आई कैन गेट द लोअर बाउंड एंड अपर बाउंड फॉर इट, एक एलिमेंट डाल के। तो सोचो अपर बाउंड मैंने ऐसा डाल दिया कि कुछ एलिमेंट्स इधर से गायब हो गया, क्योंकि मुझे एक चीज बहुत अच्छे से पता है कि इफ इट इज हाईली मोनोटोनसली इंक्रीजिंग, तो मैं डायरेक्टली एक एक करके हटा सकता हूँ एलिमेंट्स। ठीक है, व्हाट डू आई मीन बाय दैट? देखो सोचो अगर इफ इट इज मोनोटोनसली इंक्रीजिंग विच मीन्स कि डिफरेंट, अब मैं डिफरेंट कलर्स यूज कर रहा हूँ। ठीक है, ये ब्लैक वाला सबसे छोटा है, रेड वाला उससे थोड़ा ज्यादा बड़ा है, ग्रीन वाला थर्ड हाईएस्ट है, और ऑरेंज वाला जो है वो सबसे लार्जेस्ट है। अगर मुझे बाइनरी सर्च इसमें परफॉर्म करना है तो मैं कर सकता हूँ, है ना, क्योंकि ये मोनोटोनसली इंक्रीजिंग है, तो इसलिए मैं इसके ऊपर बाइनरी सर्च कर सकता हूँ। कैसे करना है? सोचो मेरे पास एक एलिमेंट है जो कि मेरा RX है, आई थिंक इट वाज RX ओनली ना, RX तो था, हाँ नहीं RK तो मेरा वो है ना, जो भी है, मतलब मुझे एक कंडीशन दिया गया था ना कि मतलब उसके नीचे होना चाहिए वैल्यूज x ऑफ i। हाँ नहीं, x ऑफ i क्या होता है? हाँ x ऑफ i, हाँ राइट। तो ये जो x ऑफ i जो है ना, ये जो वैल्यू है, तो मुझे इससे नीचे रखना है वैल्यूज को। तो अगर मैं इसके ऊपर एक बाइनरी सर्च परफॉर्म कर देता हूँ, अब सोचो मैं इन चारों एलिमेंट्स को ना ऐसे लिख दूं, 1 2 3 4। अब अगर मैं इसके ऊपर एक लिमिट अप्लाई करूं, जो कि सोचो ये वाला लिमिट है, ठीक है, कि इससे जो लेसर देन इक्वल टू एलिमेंट्स होगा उसी को बस मैं कंसिडर करूंगा, बाकी को मैं कंसिडर नहीं करूंगा। तो इससे लेसर देन, अगर सोचो ये लेसर देन है, ये लेसर सॉरी सोचो ये लेसर देन है, ये लेसर देन है, और ये लेसर देन है, बट ये ग्रेटर देन है। ठीक है, ये ग्रेटर देन है, ये पॉसिबल नहीं हो सकता। पता है क्यों? बिकॉज इट इज ऑलरेडी मोनोटोनसली इंक्रीजिंग। अब जस्ट बिकॉज ये मोनोटोनसली इंक्रीजिंग है, मतलब अगर ये इससे ज्यादा है, ये वाला इससे ज्यादा है, तो अगर ये सेटिस्फाई करे तो ये भी सेटिस्फाई करेगा। सो दिस इज व्हाट ही इज ट्राइंग टू टेल अस। वो डीपी यूज कर रहा है, फिर मोनोटोनसली वो फिर वो अपर बाउंड निकाल रहा है, कैसे? बाइनरी सर्च यूज करके। ठीक है, इज इट क्लियर? क्लियर, हाँ या ना? थोड़ा सा एक एग्जांपल के ट्राई हाँ कर लेते हैं, कोई इशू थोड़ी है, कोई इशू थोड़ी है। यही वाला करते हैं 24133। ठीक है, ये वाला करते हैं। ठीक है, दिख रहा है? करते हैं ट्राई। अब देखो अब डीपी देखना, ठीक है, आराम से डीपी कैसे दिखेगा। अब डीपी जब मैं बोल रहा हूँ, मैं उसका नंबर्स नहीं लिख रहा, ठीक है, क्या मैं ज्यादा लिख दिया? ज्यादा कर दिया 2 4 1 3 3, ठीक है। अब सोचो मुझे अब सोचो मुझे ये करना है, ठीक है। सोचो मुझे क्या बोलते इसको, 2 4 1 3 3, हाँ। अब एवरी पोजीशन में मुझे निकालना है वो LIS क्या होगा, ठीक है। तो इस पोजीशन में LIS क्या होगा? 2, ठीक है। इस पोजीशन में LIS क्या होगा? 2,4। इस पोजीशन में LIS क्या होगा? 2,4 ही होगा, या फिर 1 भी हो सकता है ना। और इस पोजीशन में क्या होगा? 2,4 1,3, ओके। अब ऐसे तुम जा सकते हो, बट इतना ही हम लोगों को चाहिए होगा, ठीक है। इससे ज्यादा हम लोगों को चाहिए नहीं। तो ये जो है ना, ये जो बन गया हम लोगों का, अब इसके ऊपर वी आर गोइंग टू अप्लाई बाइनरी सर्च, ठीक है। अब सोचो फर्स्ट जो कंडीशन है 2 और 5, मतलब 2 और 5, मतलब ये पोजीशन में मुझे 5 के ऊपर डालना है बाइनरी सर्च। अब 5 कहाँ आ रहे हैं इस 2 और 4 में? एकदम एंड में, तो मैं पूरा ले सकता हूँ। सो आंसर क्या होगा इसका? 2, ठीक है। अब नेक्स्ट पोजीशन में क्या हो रहा है? 5 और 2 उल्टा है, मतलब 1 2 3 लास्ट पोजीशन पे आएगा, ठीक है। अब लास्ट पोजीशन मुझे क्या चाहिए होगा? जो 5 से छोटा है। अब 5 से छोटा बहुत सारे हैं, ठीक है। क्या ये लास्ट पोजीशन 1 2 3 4 5 चेक कर लेता हूँ। हाँ, राइट। अब देखो, सॉरी उल्टा बोल दिया मैंने, मतलब फिफ्थ पोजीशन जो 2 से छोटा है, ठीक है। कर रहे हैं। हाँ तो कहाँ थे हम लोग? हाँ तो 5 और 2, ठीक है। तो ये जो 5 और 2 है, तो इसमें से क्या कर सकते हो तुम? ये 5 जो है, अब देखो तुम इस वाले पार्ट पे, बस इस वाले पार्ट पे फोकस करो, ठीक है। क्योंकि जस्ट बिकॉज मुझे 2 से कम रखना है, तो इसमें अगर मैं इस वाले में अगर मैं बाइनरी सर्च करूंगा, तो 2 से कम क्या आएगा? सिर्फ ये आएगा। नॉट 2 से कम, 2 से लेसर देन इक्वल, सिर्फ ये आएगा। और इसमें क्या आएगा? बस 1 आएगा। अब दोनों केसेस में वी कैन सी दैट 1 ही होगा आंसर, है ना। बट अगर मेरा 5 और 3 है, ये वाला कंडीशन 5 और 3 है, तो वो क्या होगा? ये वाला 2,4 और 1 में मुझे सॉरी 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 5 और 3 है, मतलब पोजीशन 5 है, मतलब सेम थिंग है, ठीक है। सेम थिंग है, बस 3 है मेरा लिमिट। अब जस्ट बिकॉज 3 मेरा लिमिट है, तो इसमें तो ये 2 आएगा बस, ठीक है। बट इसमें 1 और 3 दोनों आएगा, ठीक है। तो मैक्सिमम कौन सा हो गया? 2। तो दैट इज हाउ ही इज डूइंग इट, ठीक है। क्लियर है? 2 1 2, एक का लेंथ 2, एक का लेंथ 1, एक का लेंथ 2। If lengths are different, obviously the maximum one, because it is given that you have to take the maximum one now, the maximum possible length. Take the maximum one. Oh, okay. If lengths are different, then which one to take? Oh, if lengths are different, take the maximum one. If lengths are same, then take the one with the minimum values. Like जो 2 4 जो मैं अभी समझा रहा था, अगर मेरे पास एक टाई होता है, ठीक है, कि मेरे पास 2 और 4 भी है और मेरे पास 1 और 3 भी है, और मुझे क्या करना है, ठीक है। तो उसमें what you can do is take 1 and 3, because ये इससे लेसर है। तो अगर एक चीज 2 एंड 4 में सेटिस्फाई करेगा तो वो 1 एंड 3 में ऑब्वियसली सेटिस्फाई करेगा। ऐसा भी हो सकता है 1 एंड 3 में सेटिस्फाई कर जाए बट 2 एंड 4 में सेटिस्फाई ना करे, तो देन टेक 1 एंड 3। इज इट क्लियर? क्लियर है हाँ या ना? ओके चलो खत्म करते हैं वीडियो, लीव पेज। ठीक है चलो थैंक यू एवरीवन। जी वाला याद आया यार, जी रुको चेक कर लेता हूँ एक बार, बाद में देख के बताता हूँ भाई, बाद में देख के बता दो, अभी टाइम बाद में बता दो। नेक्स्ट मैं आ रहा हूँ ना कल, कल लीड कोड वाला है ना तो वो ट्राई करूंगा वो देने का, आ जाना ज्वाइन कर लेना। ठीक है देख तो खुल गया क्या? नहीं देयर इज अ ग्रेट, देखना ही नहीं है मुझे, देखना ही नहीं है ऐसे प्रॉब्लम्स कौन देखते हैं भाई? कल बता दो, कल देखता हूँ, कल सॉल्व करता हूँ, ट्राई करता हूँ। शायद मेरे से नहीं हो पाएगा। ठीक है तो देख के तो बहुत डिफिकल्ट लग रहा है। ठीक है तो चलो दैट्स इट, थैंक यू, गुड नाइट। गुड नाइट हो गया क्या? चलो गुड नाइट है, सेम ही है, गुड नाइट।